Hello, good morning, good afternoon, good evening, depending on which part of the world you're tuning into. And this is episode 5 of the OLI Conversation with Experts series. This is a video interview that we bring to you from key experts at OLI who bring extensive expertise and experience in electrolytes and water chemistry over a substantial period of time. And today it is my distinct pleasure to welcome Jim Berthold, who's our Vice President for Customer Support and Application Engineering. Jim will talk to us today about the integration of electrolyte chemistry and water chemistry capabilities into industrial process simulators and how that can deliver significant value to clients. Welcome, Jim. Pleasure to have you on board.
Thank you, Vineeth.
Today we're going to talk about electrolyte chemistry analysis capabilities in industrial process simulators. And to kick us off, the first question for you, Jim, is can you please provide us some context on industrial process simulation software? What do these products really do, and how are they different from OLI's software?
Okay, in principle, each of the industrial process simulators, including our own OLI flowsheet, they all do the same thing. It's an attempt to either simulate or design a process to gain insight in operational parameters. Most of the other simulators use equation of states for their components in the simulation, or a limited activity model, which is very local in concentration, where OLI has a more broadband and deeper understanding of electrolyte process simulator. And that's where we differ. We differ primarily in our chemistry, but our simulator does the same thing as all the other simulators.
Excellent. And why would electrolytes and water chemistry be important to these process simulators, Jim?
Okay, I guess the best way to describe this would be an example. But it's important to know that we know more about hydrocarbons thermodynamically than we do water. Water is a strange species. It's a very small molecule, yet it boils at a very high temperature. That makes it different than the other types of chemicals that can be simulated. But why do we have to understand electrolytes? Well, the example I'm going to use is a natural gas production well, where they've drilled a well deep into the formation, and they're producing natural gas, mostly methane. But with every hydrocarbon found in a well, you also have water, and water, of course, has dissolved salts into it, what we would call electrolytes. So the first part of the problem is that the natural gas coming out of the well will actually coordinate with the water molecules and form what's called a clathrate. This is what's been described to me as a large ice cube in the water. It's a highly dense region and a very low dense fluid. This ice cube is moving through the pipe at very high speed. It hits bends in pipes, it hits pumps, impellers, and so forth. And as it hits these pieces of process equipment, this high density material actually damages it. So what operators do is they add chemicals to prevent the formation. And one common chemical is ethylene glycol to this. So, and this works very well. A little bit of ethylene glycol really does prevent the formation of these high density clathrates in the pipeline. The problem is that the addition of the glycol will dramatically change the solubility of the dissolved salts, generally lowering the solubility. So we may have had a problem with clathrates, but not a problem with fouling. By adding the glycol, we foul. So we need to understand how much of each to add to prevent both the clathrate formation and prevent solid formation or scaling in the pipeline. So you need to know the electrolytes in a non-electrolyte process.
Great. So clearly there are reasons to really understand electrolytes and water chemistry and their behavior. So how do the products today, like an Aspen Plus or Aspen Hysys, Honeywell Unisim, Aviva Pro 2, or KVC Petrosim, how do these products handle electrolytes and water chemistry calculations? and what is really available for them, in terms of alternatives to choose from, and kind of what type of reactions and phenomena are they designed to predict? Can you share some insights on that, Jim?
Yeah, sure. Yeah, I'm going to concentrate my discussion primarily on Aspen Plus. It's the one I'm the most familiar with. Aspen Plus has an electrolyte activity model. As I recall, it was either the Chen model or the Chen NRTL, that stands for non-random to liquid model. It is considered to be a local electrolyte model, and it's a very good model. I'm not going to say anything bad about it, other than that the database that comes with it is much more limited than what you get from an OLI product. That requires the end user to do some optimization or data regression with actual experimental data to use the model, whereas an OLI works primarily out of the box. The other products, now going to move to HISYS, it also supports the Chen NRTL model as well as other activity models, but again, the database is somewhat limited. The products such as Unisim Design from Honeywell and Petrosim, they also have their activity models, but they're really aimed at hydrocarbons, not electrolytes, and they will make the assumption of what's called free water, which is that water is basically there, but interacts very slightly with the other fluids in the solution. Okay. So yeah, that's
excellent. So Jim, then clearly OLI has spent a lot of time in specializing in electrolytes and water chemistry over the years. What is it that makes OLI unique and differentiated when you compare us with other alternatives for electrolyte and water chemistry based expertise?
With the extensive database notwithstanding, we've spent, and actually this is our 50th year of modeling, making us one of the older simulation companies out there. We've regressed thousands of data systems with a rigorous model, so the end user doesn't have to become an expert in data regression. The other thing we've done is, because water acts as a strange phase, it's a highly polar system and generally non-polar simulations. The phase changes that are involved in water are sometimes very, very complicated, and we've developed the heuristics to solve for these highly complicated phase changes, as well as solving a massive number of nonlinear equations, as well as getting the phase separation right. So water does complicate it, and you need a very complicated model and a very strong, powerful numerical engine to solve those equations.
Very helpful. I guess that's the reason why we deliver very rigorous and accurate predictions, right? Which is sort of really what clients are looking for when it comes to understanding these different phenomena and reactions. Jim, how has OLI approached working with the ecosystem of technology vendors? What has been sort of our strategy to implement the technology integration with them? Can you talk a little bit about that, Jim?
Sure. I'm gonna divide this into classical and new generation software. So the classical guys, those are the Aspen HISYS, Aspen Plus, Aviva Pro 2, KB. I'll hold off on KBC Petrosim, but they go into the same class as well. And Honeywell's Unisim Design and GPROMs. So what we provide is a interface to their software. They provide an interface to our software. So basically, it's a door. So we build a door, and we pass things through the door based upon what they need. For example, the simulator may need to know the enthalpy of a component. Well, we will calculate that enthalpy and pass it back. We try to be simulator neutral as best we can, so that we pass the same data back to each simulator out there, regardless who makes it. So if you were to run the program in Aspen Plus for a set of conditions and then move it over to Aviva's Pro 2, you will get the same answer, because we are passing back the data in exactly the same way for each.
Excellent. And are there sort of unique differences in how we have implemented our integration with the different process simulators? Can you shed light on how that's actually, some technical details about the integration and the features that can be accessed from the OLI software inside of these simulators?
Sure. Yeah, so there's two parts to this. There's the chemistry model itself, what we would call the chemistry, and operations, how you actually do the calculation. So for Aspen Plus, Aviva Pro 2, and GPROMs, the chemistry that is built outside of the host program. So we have our own program, we call it the Chemistry Wizard, which comes along with our product and our interface. And the user physically goes outside the program, creates the interface file, and then brings that into their product in the manner that they described. Honeywell's Unison Design and Aspen HYSYS, they have their own chemistry model development tool built inside the product. So they will actually build it themselves. In fact, they built the interfaces based upon OLI's guidelines, but the interface belongs to them. They built it entirely. They just call our database, they create the interface file that we would create on their own, and that's plugged into their software. KBC's PetroSim is a hybrid of the two. They currently, for the current version of PetroSim, which I think is 7.1, but might be 7.2, they use our chemistry wizard, but it's called directly from PetroSim. So there's no leaving the software to do it. It's done internally, but it's actually the chemistry wizard. And if a user had the chemistry wizard from another program, they could use it externally, then bring it into PetroSim. So that's where it's different. However, what we like to say is that once you've created the OLI chemistry, everything you know about the host program is still true. Once the chemistry is loaded, you can use all of the unit operations inside the host programs as you always have. There's no OLI special needs there. You just have to understand what we are doing on our side of the interface. And finally, the reporting. Each product has their own way of reporting. Aspen Plus versus Aspen HYSYS, the reporting of the OLI parameters are vastly different in how it's done. OLI would help the user understand where to find that data, but they are represented in two completely different data structures.
Very fascinating, Jim. Really, good to know how much we've integrated our products into the ecosystem with the different players and the depth of expertise we've delivered over the years. So thank you so much. And thanks to everybody that's listened to this session. And stay tuned for our next session, which will be coming up next month. Thank you very much.
Thank you, Vineet.